The dashboard said everything was fine. Error rate was sitting at 0.4%, well within normal range. No alerts were firing, no red panels. But Slack was on fire. Users can't complete checkout. Payments keep failing. Anyone else seeing this? We opened the real-time metrics again. Success rate looked normal. Latency was slightly elevated, but not alarming. From a monitoring perspective, the system was healthy. From a user perspective, it was clearly broken. That disconnect is what made it dangerous. Environment. Context. We were running on AWS. The application stack lived in Kubernetes on EKS. About 120 microservice pods handled requests across checkout, payments, inventory, and user services. Traffic averaged around 4,000 requests per second during peak hours. The checkout flow depended on multiple downstream services: cart service, payment gateway integration, fraud detection, and order processing. PostgreSQL on RDS handled transactional data. Redis was used for session storage and caching. We used Kafka for asynchronous event processing between services. CI pipelines ran through GitHub Actions, and deployments were managed using Argo CD. Monitoring was built around Prometheus and Grafana for metrics. Datadog handled distributed tracing and logs. Our alerting was heavily based on error rate thresholds and latency SLOs. Initial symptoms. Users were able to browse products and add items to their cart, but when they clicked "Place order," something went wrong. The request did not fail immediately. It just hung for a few seconds and then returned a generic success message. But orders were not actually being created. Payments were not being processed. From the user's perspective, the system appeared to accept the request. From the business perspective, transactions were silently failing. Metrics showed a high rate of HTTP 200 responses, very few 5xx errors. That was the key detail. Everything looked successful on paper, but something deeper was wrong. Investigation and escalation. The first hypothesis was a payment provider issue. Maybe the external API was slow or returning partial failures. We checked the payment service logs. Requests were being sent. Responses were coming back. No obvious errors. Next, we looked at the order service. It was receiving requests and responding with success. But when we checked the database, new orders were missing. That was the first real inconsistency. We then traced a full request through the system using distributed tracing. The trace showed the request flowing through checkout, payment, and order services. Every step returned a successful status. But the order creation step had an unusually short execution time, almost too fast. That suggested it might not actually be doing the work. We pulled logs from the order service. At first glance, everything looked normal. Then we noticed something subtle. There were warning logs, not errors, warnings, messages like, "Failed to enqueue order event, retry scheduled." Those warnings were not being counted in our error rate metrics. That changed our direction completely. Root cause. The root cause was a failure in the Kafka event publishing step inside the order service. When an order was created, the service attempted to publish an event to Kafka for downstream processing. Due to a recent configuration change, the Kafka client was misconfigured with an incorrect broker address. The service could not successfully publish events. However, the code treated this as a non-blocking operation. Instead of failing the request, it logged a warning and returned success to the user. From the system's perspective, the HTTP request succeeded. From the business perspective, the order was never fully processed. Because error rate metrics only tracked HTTP status codes, this failure was invisible to our alerts. Mitigation and recovery. The immediate fix was correcting the Kafka broker configuration. We updated the environment variables and redeployed the order service. Once the service could successfully publish events again, new orders began processing correctly. We also implemented a temporary safeguard. If event publishing failed, the service would return an error instead of silently succeeding. This ensured that failures were visible both to users and to monitoring systems. Within about 20 minutes, the system stabilized. Orders were flowing again. Business metrics returned to normal. Post-mortem reflection. What actually failed was not just the Kafka configuration, it was our definition of success. We assumed that an HTTP 200 response meant the operation completed successfully. In reality, critical downstream steps could fail silently. Our monitoring focused on surface-level indicators, error rate and latency, but we lacked visibility into business-level outcomes. We also relied too heavily on error logs, ignoring warning signals that indicated real problems. The system was technically healthy while functionally broken. Engineering lessons. Success metrics should reflect business outcomes. If an operation is incomplete, it should not be treated as a success. Critical asynchronous steps must be monitored and validated. Event publishing, queue processing, and background jobs need their own health indicators. Warning logs can signal serious issues and should be included in alerting strategies. Distributed tracing is essential for understanding end-to-end request behavior. Most importantly, a system can look perfectly healthy while quietly failing its users, and that is often the most dangerous failure of all. In engineering, visibility is everything. Without it, you are flying blind. Monitor what matters, not just what's easy.